Okay, well, good day, everybody. Welcome to today's webinar. And today we have Edmund Riehle from FAST, and he's going to be presenting on leak detection in district cooling systems. And he has a case study from Dubai. Before Edmund starts, please remember that if anybody has any questions for Edmund, they can type them into the chat function at the bottom of the page, and we will have Q&A at the end. Okay, Edmund, please go ahead.
Yeah, thank you, Gary, for the introduction. And welcome, everyone. Good morning, good afternoon, or good evening. And hello to the world in this webinar. Yes, as Gary already said, I will present a case study from Dubai, Emicool, where we did a leak detection project at district cooling pipes. And yeah, as you know, probably cooling pipes is very difficult to apply like our ordinary acoustic technology to detect leaks, because you have lots of noises on the pipes due to condensers, pumps, and heat converters. So it's really difficult to detect and locate there. And also you have additionally the insulation around the pipe, which makes it even more difficult to detect it. Also with, for example, a tracer gas method, it will be very challenging because the gas will not escape through the insulation, but distribute inside the insulation. So we had to apply some other technologies there, and I will introduce you this project and how we achieved good results even in these very difficult circumstances. Just some words about FAST and me. So we are experts in leak detection since 1985, actually, or '6. Company was incorporated. And since then, we develop and produce and distribute equipment for water leak detection. And we are really very much focused on water networks, or you can also apply our technologies in any kind of pressurized piping systems. But our main clients and market is really just the water and freshwater market. At the moment, we are about 38 professionals working in the company, lots of them in development team. So we are quite innovative and have a huge spending on R&D, which is good and necessary, especially in such a niche business. At the bottom, you see some of our core products. So we do acoustic leak detectors, correlators, geophones, also flow meters, pressure loggers, pipe and metal detectors. Also a lot of software solutions now for noise loggers, which is a big business and starting to become very big for monitoring. So this is mainly our portfolio, and we are still exploring and expanding our portfolio ever since. And PipeMic, for example, is one of the unique products which came up in the last 5-6 years. I was developer of that during the time I joined FAST. Now I'm more in the business of business development and sales, but still do a portion of my time in development and innovation task force, I would say. And I'm with FAST since 9 years. Then about Emicool. So Emicool is the leading district cooling company based in the UAE, mainly in Dubai, and they provide efficient cooling water to lots of clients in the Emirates, especially like malls, commercial complexes, institutions, or also residential communities. And this is very efficient and green energy they provide to their clients. And their key figures is they have 6 operational plants all over the UAE or Dubai, with a capacity of 330,800 refrigeration tons, which is a unit for cooling water. And they have at the moment 229 employees and more than 622 kilometers of pipe infrastructure in the ground, where they have also water losses, of course, and they have the need to detect that leaks because district cooling water is, unlike fresh water, very precious. So it costs a lot of money because you also invest energy into the water to cool it, and therefore it's a really big financial loss if they lose that water. Okay, I always show this small pyramid. We call it pyramid of success, the way of the leak busters. And this shows again our whole portfolio, which is in the end a really holistic approach for leak detection. In the end, you always have the pinpointing as the real goal. So you only want to know exactly where the leak is, and all steps below are the way how to achieve this pinpointing of the leak. And in the Emicool project, we applied mainly these 3 technologies there. So we have for monitoring the ZM Ultra Mobile, which is flow monitoring, and we have the pressure logger Trulo applied. And for the pinpointing, in the end, we applied there our unique PipeMic technology for really pinpointing and locating the leaks. Okay, the project in a nutshell. So we started a project with a proof of concept in November 2020, last year, in DCP6, which is one of their plants and their district to supply the cooling water. And this has about 46 kilometers of cooling pipes in the ground, which is supply and return. So both are, or each is about 23 kilometers of network. And the pipe sizes ranges from DN 150 to DN 1100. So you can imagine already very large diameters are also in the ground, which makes it additionally very difficult to detect the leaks there. And previously, Emicool was partnering with some of our competitors and tried to locate the leaks with the ordinary acoustic methods, especially like with noise loggers and correlators. Also tracer gas they applied, and all of this failed and was not successful, so they couldn't locate any leaks with this kind of technology. And I mentioned already the reasons in the beginning. It's a lot of like ambient noises you have on the pipe naturally. And therefore, we choose in this project a combination of differential flow measurement, pressure management, pressure measurement, and our unique PipeMic technology to locate and pinpoint the leaks really precisely in the end. Okay, the choice of equipment we did, you see here a small map with some of the chambers where we applied 18 flow meters called ZM Ultra Mobile with us, with 2 sensor pairs. That means we measured on the supply and the return on the same time, and I will show you later how we calculated this. Then we also applied 40 pressure loggers in the zone to monitor the pressure along the pipelines to see pressure drops caused by leaks. And then we also supplied PipeMic XL, which has a pushing distance of 150 meters for the larger diameters, a PipeMic M for like medium-sized pipelines, and then smaller diameters with 50 meters cable or push rod, and a PipeMic Flex for like a lot of bends in the pipe to be able to push around, and also a cable or pipe locator VScan is called. It's not our own, which we manufacture. We only resell this, but this is necessary in the end to locate and pinpoint the exact position of the PipeMic head to to have the exact position of the leak. Okay, about the ZM Ultra Mobile. This is a mobile flow meter with extreme long-lasting battery. This is important because in the chambers in Emicool we don't have a power supply, and therefore we had to choose this equipment with a very long-lasting battery. It's with one battery up to 1 year in cyclic mode in 5-minute interval. And it is also IP68 and very ruggedized. This is also important with cooling chambers. You always have the problem with condensate building inside, so you have to have really ruggedized equipment. And also here we applied GSM and GPRS modems inside the device, so we already transmit that data recorded autonomously to the cloud or to the SCADA system of Emicool. I'll show you later a little bit more. And also here we applied, like I already mentioned, 2 sensor pairs to measure the flow on the supply and the return in the same time. So this is the operation principle, how we did this with the ZM Ultra Mobile. You can see here the differential flow reading, which is on the supply line V1, so the first velocity we're measuring, and on the return line we have a reverse installation of the sensor. So that means we have a negative low velocity on that point. And you see here the equation, the device, the ZM Ultra Mobile is measuring. So at the moment, we are working really to measure 2 flows very individually to monitor them. But we are already able to measure 2 paths, not individually, but on the same pipe. But at the cooling pipes, it's very easy because both supply and return have the same properties, the same dimensions. So we could apply it to 2 separate pipes and monitoring there the flow velocity. And in the end, this equation is used for having the mean velocity usually measured at the same or at the same pipe as shown in this small picture here with a 2-path measurement. But we did separate the 2 passes on 2 different pipes and measured it. So in the end, if there is no leak after the supply pipe and before the return pipe, the mean should be 0. And if there is a deviation, it should be positive. If it's negative, then you know, okay, you cannot add order somewhere in between. That's the wrong reading, of course. But if it's a positive reading, then you have a leak somewhere in between, and I will show you that how it looks like in the following slides. So these are some pictures of the installation of the ZM Ultra in the chambers. We mainly used V-Pass on the small diameter pipelines up to DN900. On the larger diameters, we used the set mode to install the sensors on the opposite side of the pipeline. And you see here also the installation. It's pretty easy. You have this nice guiding of the installation during installation, where you see the gain, the quality, and the spacing of the 2 sensors. The gain is here so high because we have naturally already a lot of noise on the pipe. We had to use a very high gain. It's still very good reading, but we had to use a very strong signal on the pipe to penetrate the liquid. Okay, this is some screenshot of or some small video of one of the pipes. It was exactly in this chamber. So we have here the supply line, and we have here the return line. And you can see already that we are detecting a leak in between, which has about 25 liters per second leak rate, quite high leakage rate. And you see here the two different flow velocities which we are measuring. This is the pass 1 is here on the return, and the pass 2 is on the supply. So we have here the negative flow velocity, and there the positive flow velocity, and the flow velocity of the supply is bigger than on the return, and therefore we have this deviation. And we can see directly the differential flow. And this is the leak rate, which is really happening in between the supply and the return pipe there. Okay. This is another pipe, DN900, and this shows nicely that there is no leak in between. So there is a very small, let's say, negative flow velocity or flow minus 1.1. That means there is no leak in between. Yeah, we're still evaluating and defining at what differential flow we really can say that this is absolutely a leak which is occurring in these sections. Then we also installed pressure loggers. Trulo 3, it's called, the product from us, a very accurate pressure logger. And also the ZM Ultra has the capability to attach I/O, like additional sensor, which we applied the pressure sensor there. And together with the flow data and the pressure data, it's a very high accuracy. We could tell that on that sections of pipeline, we have a leak. And yeah, that was the case there. Some more pictures of the installation and the devices we used here. So the pressure logger has a 1/2-inch thread, also the additional sensor for attaching to the ZM Ultra has a 1/2-inch thread, so we connected it directly to the air valves on the cooling pipes and monitored the pressure along the run of the pipe. Each chamber we placed 2 loggers, one on the supply and one on the return, again to have a full data analysis of what is happening. Okay, the data transfer, especially from the flow meter and the pressure recording, is directly transferred to the Emicool SCADA system. So it's centralized and accessible by the operators there, and they can immediately also react in case of there is a burst or major incidents, and they see directly what is happening and have that data live in their system. This is a very big advantage, and they can react very, very quickly with this system. And then, okay, with the before mentioned technology and methods, we can only sectionize the leakage. So we can say, okay, in between here, we have somewhere the leak, but we are not able yet to really locate and pinpoint it. And therefore, we are applying now, after that step, when we identified the section, the PipeMics, the unique PipeMic series from FAST. Those are the 3 devices we supplied to Emicool, PipeMic XL with 150 meters, PipeMic M with 50 meters, and the Flex for very lots of bands and small diameters. We also apply the PipeMic Flex in their networks. The very big advantage of this device is we have here a sensor head with acoustic and also a search coil for later on really locating the tip with a ordinary cable and pipe locator. And also the push rod has a conductor inside, copper wire, which is able to trace later on, so you can also trace the run of the pipe. And the whole thing also has a water lock to keep the pressure inside the system, which is of course necessary for having the leak sound. If there is no pressure anymore in the system, the leak sound will be disappearing in the end. So it's a water lock for up to 16 bar water pressure. And we have a disinfection container here as well, which is not really necessary for Emicool because they use circular loops, sorry. And they are, it's not drinking water, so there would be no need to disinfect it, but this was mainly developed for freshwater applications, and therefore the disinfection fixture is really necessary to make sure you have a safe application in the freshwater pipelines. And yeah, the signal in the end is transmitted here through this small electronic box by Bluetooth to a speaker. And you can listen directly to the leak sound or to the sound. I will show it later in the video. When you push inside the rod, and it's really easy to distinguish when you approach the leak and if you get further or if you are still before the leak. This is very easy, and even unskilled operators can use this technology from the beginning without any problem. Together, like I said, with the pipe and cable locator, you can connect here to these two jacks on the electronic unit, the signal of the cable locator. And as mentioned already, we have a search call in the tip. So once you heard the maximum sound intensity, you leave the tip on that position and you connect the cables, both signal and the ground, the earth, to these two jacks, and then you will radiate out the maximum magnetic field through the search coil, and you can really precisely locate the exact position of the tip, which gives you 100% success rate, and there is no misinterpretation possible. Unlike with correlators or geophones or even tracer gas, you sometimes don't get the exact position because there are some interpretations or some even wrong data you use, and the PipeMic is really there 100% success. This is some application pictures. So you insert it usually on freshwater pipelines. In Emicool, we have the already existing air valves and washouts and access points. So there it was pretty easy to insert it. We only opened the air valves and amended it slightly, put the right adapter, some plumbing work, and then we connect the water lock, and we were able to push it inside. And yes, and in the end, as mentioned, it's really very accurate, 100% success rate. There's no interpretation possible. Here I have a small video for one of the application, one of the leaks we detected in the network. So there is one guy in the chamber, in the manhole. Another one is helping with unwheeling the rod and pushing the rod inside. So at the moment, you don't hear any leak yet. So now they pushed further, and you already can hear now in the distinct some sound, some leak. And as further they approach the leak, as more intense the signal gets. So now they are almost on the leak, and you will hear now they will push it a little bit further inside. And I will tell you exactly when they are on the spot. So not yet on the spot. So with this one, it was a little bit more difficult to tell exactly the position, but now we are on the spot, and now we are further. So in this case, it was a larger pipeline, and the noise was not really very precisely just on the position of the leak, but you could hear it a long distance before and a long distance after. And that is the leak in the end when they excavated it and cut the insulation. So it was on a joint or like a service connection where they had it on the main pipe, and we inserted it in the main pipe, and the leak sound really distributed along the pipe, and we could hear it a long distance before and even after the leak. And therefore, you could not really identify it very, very precisely. But if you have some experience with the PipeMic and you know what to listen to, and in the end, I told you, now we are on the leak. This was really the maximum intensity. You have the highest frequencies and you have the maximum intensity of the leak. And that was the case on this position where we had the joint, and in the end, we had this really precise excavation. Some more pictures of the excavation. So just to have some more impressions on the project and what they are doing. Yes, so this is here the cooling pipe. They still had to cut the insulation to see the leak. You could see already the cooled water, chilled water, but yeah, the leak was hidden beneath the insulation, so they had to cut the insulation in the end as well. And yeah, that's all for my little case study. So the conclusion here is that the combination of differential flow measurement, pressure measurement, and our unique PipeMic solution is proven to be successful in even these very difficult circumstances. And it was a job of about 2 weeks for 2 teams with Emicool to install all the equipment, including cutting the insulations. So that was a pretty tight job they have done, and a very, very good job. And we did this during COVID time, I also mentioned here. So we everything did by video conference. I've been not in Dubai personally for that project, which made it even more difficult. But in the end, everything worked out. I only had to assist a little bit. So it's also like showing that it's pretty easy for them to install it by their own with our help in the end. And yeah, the installation was finished end of January 2021, and the data integration process is at the moment ongoing, but it's finalized probably today. So this is additional value and a very big yeah, point for them to have all the data on their centralized SCADA system, and being able to identify leaks very early and monitor that data, and yeah, as more data they have to analyze, and as better it is for the system in the end to identify leaks. And we already were able to detect and locate 5 major leaks with our system, and especially the PipeMic. And yeah, it was not a very high investment they had to do, unlike other technologies and the project they have done in the past, which didn't add any value and was quite expensive. It was a low investment cost, and also the installation cost was very low. It was only a job of 2 weeks, and therefore they expect a very huge saving on the leak reduction activities in their network. And yeah, so it's also from the economical side a very big success. And yeah, project just finished, but this was the installation. We still looking towards the future and applying these technologies to the other zones of Emicool to also precisely locate and detect the leaks in the different other districts they provide the cooling water. Okay, that is all for my case study, our case study in Dubai. I hope you liked the presentation, and I see that there are already some questions in the chat. And my special thanks here at that point are to the Emicool team, especially Mr. or Dr. Adit Mubadar and Hani Algul, and Iyad Titi, project coordinator, and Abdallah Mahmoud Saikar, which was the project manager and network manager, especially for the DCP6, where we conducted the project, and the installation and operation team, where I regularly, even during Christmas, stay in contact with them, and we managed to install everything right on schedule. Okay, now I'm looking forward to the questions, and if you have some more questions, just don't hesitate to ask.
Thank you very much, Edmund. That was a good presentation, and I think it just highlights how much of an investigator people have to be to go out and find the leaks. It's not just a case of putting some equipment down and leaving it. You've got to really go out and look for those, work hard to get the leaks. Exactly, yeah. We do have a few questions. The first one is, what is the battery life with 5-minute intervals for the ZM Ultra Mobile?
Yeah, I mentioned in the slides for the ZM Ultra. Maybe I go back. It's up to 1 year autonomy you can achieve with the ZM Ultra Mobile in cyclic mode. Cyclic mode means between the 5 minutes it sleeps, and then it wakes up and takes the reading and goes back to sleep. And also together with the GPRS, with the GSM modem, you can send this data in a 5-minute interval, and that means it connects to the mobile network, sends the data, and gets back to sleep. So it's possible to have a 1 year autonomy without recharging the battery.
Okay. We have a few people that have been asking for the presentation files. I'm not sure if you're willing to give those out.
No, it's possible, and I know also you record it and you will put it online on YouTube.
Yeah, it will be on. It will be on our YouTube as well. Do you have a slide with your email address on?
Yes, I do. In the beginning, there was my email address.
Okay, there you are. So there's Edmund's email address in the bottom right-hand side. So if anyone is interested in getting a copy of the presentation, then please email Edmund directly, which is from the email there. We have another question from Robert, which is, what is the operating pressure of the DCS?
The operation pressure is about 6 bars.
6 bars, right, okay. And we have another one from Eric again, which is why acoustic method correlation didn't work? What is the pipe material?
Yeah, the pipe material, this is another difficult thing, is GRE. So it's glass fiber reinforced epoxy, which is widely used even in freshwater in the UAE. And this propagates the leak sound not very sufficient as well. So, but the biggest issue here, why correlation and other acoustic methods don't work, is that you have a lot of disturbing noises by condensers, by heat exchangers, by pumps, which keep the circulation running. So therefore, it's impossible if you here in the chamber already, if you go in the chamber, you could hear like that loud noises, and therefore the sensor could not pick up leak sounds, even there are like bigger leak sounds, because the ambient or disturbing noises are so high.
Right, okay. We have a question from Joanna, which is, how far apart were the differential flow meters, and did the 18 pairs cover the whole network?
Yes. Slide where I have the map. So in the end, the distance between two flow meters or two chambers is about like a few kilometers, let's say about 1 to 2 kilometers. And yes, we covered the whole network with the 18 units. So we applied in almost all of the chambers the flow meters, and since we have the supply and the return in the same chamber, it was pretty easy. So in the end, we are doing 36 measurements there, and it was possible to cover the whole network.
So you were using existing chambers that were already in the ground,
yeah. Yeah.
Right, okay. We have a question from, I'm not sure who it's from, but it says, how long did the PipeMic 11 ever go forward to reach the leak? And the pipe diameter with a PipeMic is ever detected. So how far did you have to go down to detect the leaks with the PipeMic, and what sort of pipe diameters have you used it on before?
So the PipeMic M, which was mainly used for the first 5 leaks, but we also want to apply the XL, which has a thicker rod and is more stiff, so you can achieve greater pushing distances. But the M has only 4.5 millimeter push rod, and therefore it's not suitable for large pipe diameters. You can imagine, as larger the diameter of the pipe, as more space the push rod has to curl up inside, and therefore it gets more difficult to break the rod in the end or make a knot or whatever. So yeah, this was the M should be applied like only for the smaller diameters. There we applied it up to DN 300 or 400, I think. Not 100% sure. This is the team of Emicool. They now do it independently. I just get some information from them, and I did get those information I showed just a few days ago. Put together this presentation, but the PipeMic XL with the 9 millimeter rod you can apply on the larger diameters, and you can push up to 150 meters without like a big problem. And the maximum distance they pushed inside was with the M, was the full length, the whole 50 meters of it. And yeah, in the end, it was in the DN 300 or 400. was not a complete 50 meters of pipe, but it was a little bit less distance because the cable had some space inside to not lay straight. But yeah, in the end,
yeah, I assume you can push downstream with the going with the flow, but what about against the flow? Is that possible as well?
Yes. That's a big advantage of this system, that you, with the push rod, are able to push against the flow. So at the position of insertion, you have in both directions, in the end, the full length of the rod to be pushed.
Okay.
And the flow velocity is not that great there. About in average 0.5 to 1 meter per second. Therefore, it doesn't affect the small cable push rod inside if you push against the flow.
Okay. We've got a question from Nguyen, which I'm not sure if you can answer, but could you share some information about the SCADA software system? Does the software help you to investigate the leakages too?
I don't know exactly what Emicool is using and who built it for them. But that will Emicool be able to answer. I'm sure they are happy to answer this question. But what we did is integrate our data on their SCADA. So this was within the scope of the project, and this is about to finalize. The TNC, testing and commissioning, is just the end of this week, so today, because in Dubai we have weekend on Friday.
Yeah, okay. We've got a question from Vivian about, she says the cover locator has some problem in sensitivity. I'm not quite sure what she means by that. Would you know what she means by that?
Cover locator. Cover locator, maybe that is a question detector to our portfolio. Yes, maybe she's meaning this device here in sensitivity. I don't know, probably maybe she can write me a personal email to understand what she's asking.
Okay, so I'm sorry, Vivian, we don't fully understand what you're asking there, but if you can email Edmund, there's his email on the screen, then he'll be able to come back to you with any with a quick answer for that.
Sure.
Okay, so if we don't have any more questions from anyone else, I'd just like to say thank you, Edmund. That was interesting. To see a case study that's gone on like that, especially during COVID times where you have to do it remotely, which is, I can imagine, is interesting to try and train people over the telephone. But yeah.
Yeah, it was possible, and the team was very dedicated and enthusiastic, so which is very good result.
Okay, well, thank you very much, Edmund, and we'll stop the recording now.